So today what I'm going to do is review how we were able to utilize our graphing calculator to solve part of the problem here with our quadratic application problem. So we were able to fill out this table of values, doing some things by hand. Okay, there was a lot of work that we did attached in our notes, but I want to review how we used our calculator to find some of those values as well as confirm some of those values. So this is basically for those of you that were in class that have your notes. This is just kind of a recap of how we were able to find these values using our calculator. So the first part A asks us to find the height of the function when time was 1/2. So after 1/2 of a second of being in the air, how high was the object? So at the top of my page, I've written the function that we came up with. After we read the problem, we were able to identify our initial velocity, our initial height, and the force of gravity. So the only thing I left out was the +0, assuming that the object was hit from the ground. So in this case, we could do all of this by hand, but I'm going to show you how to use the calculator to evaluate these parts. So the first part here, h of 0.5, we want to know what is the height after the ball has been in the air for 1/2 a second. Sorry if I'm repeating myself. So what I've done first is I've entered into my calculator the equation. The 4.9 came from multiplying the -1/2 and the 9.8. X squared, okay, that's just our independent variable instead of t. And then if I press graph, I can actually see the path of the ball, okay, where it started here off the ground, flew up, landed on the ground again, okay. All of this would either be off of a cliff. This is kind of, obviously this part doesn't correlate with the problem unless we were passing it from under a cliff, but let's just ignore that. So in this case, the first part asks us to find, after 1/2 a second, how far was the ball in the air. So the easiest way to do this is to use your table. Now if you go directly to your table, most of your tables will all go by ones to begin with. So in this case, I couldn't find 0.5. So what you can do is you can go into your table set. It's right above the word window. It says TBL set. It's in blue, so you have to press the blue and then that button. And you can actually change what your table goes by. So if you want to go by 0.5, now if I go back to my table, I can see I can go down to 0.5 and find that the height of the ball is 8.575. Now another option, instead of trying to scroll, because what if I put in 55.5? It might be annoying to scroll all the way down to 55.5. Instead, what else you can do in your table set is you can choose where to start. So right now, notice it says 6. If I go back to my table, the first entry on my table is 6. So if you're just trying to evaluate at 0.5, you can go directly into table set and just plug in the value that you're wanting to check out. So you want to see when x is 0.5, what is y? And we see here again that the height of the object is 8.575 meters. And again, let me find my work. We did this in class by plugging in 0.5 for t, evaluating it, and we got the same answer. A second way to evaluate a function when you have a graphing calculator is you can actually do it off this screen. So in this case, on this screen, you're going to want to go to the calc menu. So you're going to have to press this button, or blue, and then trace. And in this case, the first option says value. So in this case, they actually are asking, okay, what value of x are you interested in? Let me go ahead and zoom in. We're interested in when x is 0.5. So then if I press enter, it will immediately tell me what the y value is. And furthermore, it'll also show me on the graph where that is. So after 1/2 a second, there is my height, and there's the positioning of my ball. That's another way to evaluate using your calculator. For part B on our table, they asked us to figure out the time at which the height would be 14.7. So in this part here, what I've done is I've plugged in 14.7 for my height, and in this case, I'm solving, sorry, there should be a t here, for a time. Again, I'll show you guys a couple ways to do this. You don't have to do it multiple ways. Just to let you know, you can do it by hand, and we did it in class by hand by using the quadratic formula. So we went all the way through, did all this work, and ended up getting x's 1 and 3. I'll show you how to get those answers, again, using your calculator. One way is you're trying to figure out where this graph which is the one that I have graphed here, will intersect with this graph? When will it equal this value? So what you can do is you can actually enter both of these equations as, or these expressions as separate equations. So you could enter this under y1 and you could enter this under y2 or vice versa, it doesn't matter. So since I already have something under y1, I have the right hand side, I'm going to go down to y2 and enter the equation y equals 14.7. That will be a horizontal line at 14.7. Let me look at what my window is. My y max is now 40. I don't know that I need it that big. Let's see if I can reduce it to 30. Yeah, and I'm going to get rid of some of the space since I don't care about that right now. So, oh, there's my other line. So I'm going to reduce my y minimum, give it a little bit of a buffer so I can see my x-axis. Oh, sorry. Delete. Graph. There we go, and here comes my line 14.7. So we see clearly that the ball is going to hit 14.7 in two places. So let me go ahead. In fact, since I just right now I'm interested in this area, I might even want to just see this part of my graph. So what you can do is get rid of even more y minimum by making the y minimum positive. So let's make it positive 10. It just has to be less than the y max always. Again, I'm just playing around with my window. Let's say I don't care about this space. So maybe I make this 10 to 20 instead of 10 to 30. In any case, let's go ahead and find this value. So again, I'm trying to find where the parabola intersects the line. So how we do that is we go, since we're at our graphing screen, we're going to go to the calc menu again, previously where we use value, and we're going to go down to intersect. Where do these two graphs intersect? So right now you see this little blinking button. We can only use our right and our left cursors. It says first curve. Just make sure that that little, we'll call it a fly, I don't know, no, that's weird. I don't know, that little turtle guy, is on the first graph. So sure enough, it's just saying, yes, it's on my parabola, and then saying, is it on my second curve, meaning graph? Yes, it's on the line, enter. Then it says guess. So move the little guy close to the point that you're looking for. So I'm going to find this first intersection point. Press enter, and there, sure enough, it says that when x is 1, both graphs are at 14.7. Furthermore, if I go to my table, and I go down to 1, both my parabola and of course my horizontal line both have the same output value. That's where they cross. So sure enough, 1 is a solution of this equation. If I plugged in 1 for t here and 1 for t here and I evaluated, it would make this side equal 14.7. To get the other point, we would just have to repeat the process. Second calc, intersect. Is it on the first curve? Yes. Is it on the second curve? Yes. Now guess. This time I have to move closer to this guy. And there we go. At 3 is another solution. If I confirm with my table, again, if I want to change my table to going back by ones, I can always do that. Table. There. Oh, that was weird. Did I not change that? Oh, since it started at 0.5, it went by 1. So it was, I get it. So it would be 1.5, 2.5, so I have to have it start on an integer as well. There we go. So that just made it easy for me to see that sure enough, at 1 they're both at 14.7 and at 3 they're both at 14.7. Next, part C was very similar to part A. It just wants to know what will be the height when the time is 2.5. So using our calculator, it's really nice. I'll just go to table set, start at 2.5, go to my table, and there I am at 18.375. Okay, and of course I need to make a note here that I use the table on my calculator. On the homework, for the homework problem, I want you guys to work out by hand at least 2 to 3 of the problems, and you can use your calculator to check, but I don't want you to do it all on your calculator because I want to know that you know how to get it without the calculator as well. Part D asked when the ball will hit the ground. So here's the parabola. We want to know when it hits the ground. The height at the ground is 0. So again, we're looking at the intersection of the parabola with this line. This line is y equals 0. But keep in mind, guys, the line y equals 0 is your x-axis. It's this line right here. So we're just trying to look for, here it takes off, here it lands. So we're looking for the x-intercepts. If I go to my graph, Oh, I had changed my window. I need to be able to see my x-axis. Window. In fact, I'm going to get rid of that line since I don't care about 14.7 anymore. So I just go to clear. Go to my window. I need to see below my x-axis. I'm going to go ahead and give it a little bit of a buffer. I don't really care so much. Let's see if we can avoid it down a little bit. I'm just making my window a little bit different. Alright, so I know that that's 0. So I know that one of my solutions will be 0, but I'm trying to find the other one. So if I go to second calc, I want to go to not value, I want to go to 0, which is your x-intercepts. Left bound. So I know that this point here, to the left of that point, the graph is above the x-axis. So to the left of that point is technically really anywhere above, but it's best if you can get fairly close to that point. So there, it's above, hence it's to the left. Enter. Right bound. To the right of that point, the graph is below, so I have to move my little turtle guy to the right, enter, and then guess again. I move close to that point, enter, and sure enough a 0 is at 4. So after 4 seconds it hits the ground, so t equals 0 and t equals 4 when it takes off right here and when it lands right here. And then part G asked to find the vertex. They wanted to know this point, but if we know if this is 0 and this is 4, the vertex always happens halfway between, so 0 plus 4 is 4, 4 divided by 2 is 2. So that means my axis of symmetry is 2. So that means that I want to figure out my vertex is going to be at 2 some number, so therefore I want to evaluate h of 2. So if I go to my table set, I can go ahead and just pick 2, go to my table, and figure out that the highest point is at 19.6. h of 2 is 19.6. Now if we didn't know that it happened after 2 seconds, if you just had any old graph or any kind of picture and you're trying to find that vertex, what I always do first is make my window a little bit higher than the vertex so that you have a little space. So I'm going to go a little bit higher. I'm going to go to 40 so that we're not cramped at the top of our window. And then again, we're back at our graphs, so we're going to go to our friendly calc menu where we've been able to use our 0, our value, our intersect. So now we're going to be using these two. Now in this case, this vertex is a maximum because the vertex, the turning point, is the highest point on the graph. So I'm going to go to option 4. So I'm trying to look for that point, so that to the left, no, that points to the left, enter, move over, that points to the right, guess, enter, and there it says, now technically guys, your vertex is kind of like a limit, like it's reaching that point and then dropping down, so it's going to not look like it's exact, so but we understand that's going to happen halfway. So in this case it would just be after 2 seconds it's going to reach a height of 19.6. So same answer that we got on our table. Alright, I think that is it. If you guys have any other questions on how to use your calculator, I think we've gone over all of these features that we need to, these first 5, which are the ones that you guys are going to be using. These 2 are dealing with derivatives and integrals, that's calculus stuff. But if you have any questions about using your window, table set, the calc menu, the table, we're not going to use trace very often, so don't be tempted to use trace. We will go to the calc menu behind it by pushing the blue button first. Also, if you're ever having trouble, if you go to y equals, be sure your plot is not highlighted. If your plot is on, your calculator thinks that you want to plot data, so that's something else. If we start graphing points in our statistics button, if you go and edit the data and you start entering lists of data, it's going to try to plot points. So for example, if I tried to plot the point 218, so let me just show you what this does. This is kind of random, but now if I press graph, it graphed the point 218 along with my parabola. Okay. Whereas if you didn't have any data there, so if you go into stat, edit, and you go ahead and clear your data, clear, move away from it, and I go to graph, it's going to say error, invalid dimension, and you're going to be like, what's going on? But when you press y equals, the calculator thinks you want to graph this and plot data, but it doesn't know what to plot because there's nothing there. So be sure that your plot is turned off by highlighting it, and then I'm just pressing enter, and then you have to move away from it, and then it'll be deselected, and then it will just graph whatever your equation is. All right, this is definitely a longer video. I hope it was helpful. Feel free, on Friday you will be able to use your calculator. Be sure you also know how to show evidence working by hand. It's just great to be able to use your calculator to check and confirm your solutions. All right, you guys, have a great night.